Hello and welcome to today's lesson where we're going to look at the transformer in the magnetism and electromagnetism topic in GCSE Separate Science Physics. So in today's lesson we're going to look at the mathematics of the transformer. So we're going to try and calculate values of a transformer. So if we are successful and we learn in today's lesson, we should be able to describe what a transformer is, calculate values of a transformer system and explain how a transformer works. So by looking at the GCSE Separate Science specification for AQA, we can see it's in 4.7.3.4 transformers, which is a higher tier only part of the specification. Now transformers are used in the national grid to change the potential difference and the current at different points. Now it's important to see which transformer you are using, and you can do that by observing the amount of turns of coil in each coil on your transformer. So it's important to note that the number of coils in the transformer relates to the amount of potential difference in the wires. The more coils or turns of wire, the greater the potential difference in that particular coil. This happens as the greater the number of turns, the greater the change in the field lines cut by the transformer wires. So what this means is that when the magnetic field alternates in your transformer, it produces a larger induced potential difference. Now in a step-up transformer, there are more turns on the secondary coil than the primary coil, as there's a greater potential difference on the secondary coil compared to the primary. So if you see more turns on the secondary coil compared to the primary coil, it is a step-up transformer. Whilst for a step-down transformer, there are more turns on the primary coil as opposed to the secondary coil, because the potential difference decreases in a step-down transformer, so you have less coils in your secondary coil. Now remember, the more turns in your coil, the more potential difference. So just remember, in a step-down transformer, there are more turns on the primary than the secondary, but in a step-up transformer, there are more turns on the secondary than the primary. Now it's important to note that this relationship can be linked as a formal equation, and that is that the ratio between the potential differences in the coils is the same as the ratio of the number of turns in the coils. So we can say primary voltage over secondary voltage is equal to the number of turns on the primary divided by the number of turns on the secondary, which links into what we said before, that step-up transformers have more turns on the secondary than they do on the primary, while step-down transformers have fewer turns on the secondary than they do on the primary coil. So let's have a look at an example of this in a calculation. Now a transformer could have 20 turns on the primary coil and 40 on the secondary coil. What is the output potential difference if the input potential difference is 500 volts? Well, what you can do is you can work this out, and the answer is 1000 volts. Now to work this through, what you would do is you would firstly write out your transformer equation. You would then look in the question and substitute values from the question into that equation. You then rearrange your equation by placing the values at the bottom at the top of the equation. Now I think it's always important to split your rearrangement into two different steps so you don't make a mistake doing this. So you will see that it will be 20 times by Vs, as the bottom value of Vs goes to the top on the other side of the equation, and the same for writing 500 times by 40. You then want to make Vs the subject, so then we'll remove that 20 on the same side as the Vs, so it's going to be 500 times by 40 over 20, which equals 1000 volts. Now ensure you've got the right number of significant figures in your answer and the correct units. Now just as a logic check, you expect that secondary potential difference to be higher than the primary because the secondary coil has more turns and it goes in the same ratio. So you'll notice that as the number of turns from primary to secondary has doubled, the potential difference from primary to secondary has also doubled. So it's always important to write out your answer to a question like this, showing your equation, your substitution, your rearrangement, and then your final answer very, very clearly. Now the other thing you've got to be aware of for transformers is that transformers can be considered to be 100% efficient. This means that for a transformer, the electrical power input is equal to the electrical power output. Now this is because we assume the transformer dissipates no energy to the surroundings when it is operating. Now we know from previous work that electrical power is equal to potential difference times by current, so we can say that Vp VP times by IP is equal to VS times by IS, because you know VS times by IS is the power output, it's the power of the secondary coil, whilst VP times by IP is the power input, the power of the primary coil. Now, as the power is constant for a transformer, this indicates that as the potential difference increases, the current has to decrease, and that as the potential difference decreases, the current increases, which shows us why a high potential difference is needed in transmission cables in our national grid, because when you have a high potential difference, it lowers the current and therefore it reduces the energy loss in the cable, because it's the current going through the transmission cable that will produce energy dissipation. So let's look at an example calculation. A step-down transformer is used to step down an alternating potential difference of 230 volts to 12 volts to supply electricity to a 12 volt 2.5 amp lamp. Calculate the current in the primary coil of the transformer when the device is switched on. So what we can say is that this primary current is going to be 0.13 amps. How do we know this? Well, we write out our equation, we then substitute the values from the question into the equation previously, and then you rearrange your equation now to find IP. Now again, I split my particular work into two steps. I substitute the values in first, I then rearranged. I then write out my final answer, ensuring I got the correct units and the right number of significant figures. Now again, do a quick logic check. You'd expect the current to be lower in the primary coil because the actual potential difference has increased in the primary coil compared to the secondary. So when one goes up, the other goes down. So if the potential difference is larger in the primary, the current is going to be smaller. Now always show your answer to a question like this with equation, substitution, rearrangement and answer. So what do we know? A basic transformer consists of a primary coil and a secondary coil wound on an iron core, which an iron core can be easily magnetized. You should know the equation of Vp over Vs equals Np over Ns, and Vs times by Is equals Vp times by Ip. Now you should be able to explain how the effect of an alternating current in one coil in inducing a current in another is used in transformers, explain how the ratio of potential differences across the two coils depends on the ratio of the number of turns on each, and finally calculate the current drawn from the input supply to provide a particular power output. So if we've been successful and learnt in today's lesson, we should be able to describe what a transformer is, calculate values of a transformer system and explain how a transformer works. So I hope you've enjoyed today's lesson on transformers, which is part of the magnetism and electromagnetism topic in GCSE Separate Science Physics. Thank you very much for watching and have a lovely day.